practice the simplification and using and finding average rates of change using the difference quotient. Alright, so this is, and a lot of times it's the algebra, so the calculus isn't necessarily hard to understand, but some students will get stuck on the algebra, so that's why we're practicing the algebra. Alright, now before we get to the sort of the next big topic, which is 1.4, which we need the difference quotient for, so we're practicing it now. Alright, you will have to be able to use the difference quotient for linear, quadratic, or simple rational functions. Actually, I forgot cubic in there as well. And a simple cubic. Alright, you have to, so whenever they say the difference quotient, what they mean, it's the f of x plus h minus f of x all over the divide by h, which again can't be 0. Right, represents the change in x. Alright, remember that's what it represents. And actually the goal is to get rid of that divide by h, to get rid of the h part so that I can use 0. Alright, but right now we're just practicing it. So we're going to find the difference. So part A is find the difference quotient. Part B is then to use the difference quotient to find the average rates of change for each of these filled out. So when x is 1, and then different change in x. So the first change in x is a tenth, a hundredth, and then thousands. Because we're doing small change. And there's a reason why, and we'll get to the reason why in the next section. Alright, so we're going to find the values. We're going to plug those in. But before we do that, we're going to do part A. Alright, so the first function is a simple, so this is what I mean by simple rational. Rational means a simple division. So simple rational would mean a number divided by x, or maybe a number divided by x plus a number. Alright, so the function I chose was 5 divided by x. Alright, so A, the first part, is to find f of x plus h minus f of x all over h. Alright, so step 1 is plug it in correctly. So the first thing we're going to do is we're going to write x plus h in my function. So instead of the x, it's going to be wherever there's an x value, I replace it with an x plus h. So in this case, instead of 5 divided by x, it's going to be 5 divided by x plus h. Right, then minus the original function. And the original function means it's the original function without changing anything. So it's just minus 5 divided by x. And so you type that as. And again, with fractions, I always put parentheses around them so that, again, remember it's minus that entire fraction. And that's the entire fraction. So that's the first part. There's f of x plus h minus f of x. And then it's that whole thing, divide by h. All right. Now, the goal, the manipulation, so now we're going to manipulate it and simplify it. The manipulation goal is to get rid of the divide by h, because I want to be able to plug 0 in. I can't plug 0 in now, because I've got the divide by h, but eventually that's what we're going to want to do. Alright, so whenever it's a rational function, so now it's a complex fraction. Whenever you're dealing with a complex fraction, we want to clear out the little fractions. And so I'm going to multiply the top of the fraction, the big fraction, if you look at the whole big thing, by the lowest common denominator. Well, there's 2 denominators. There's an x and an x plus h. So that's what I'm going to multiply by. I'm going to multiply by x, and I'm going to multiply by x plus h. So up top, I'm going to multiply by x times x plus h. Well, in order not to change the value of the fraction, whatever I do to the top, I have to also do to the bottom, because I can only multiply by 1 and not change the value of the fraction, right? So as long as I do the same thing to the top of the fraction as I do to the bottom of the fraction, I've not changed the value of the expression. So up top, I'm going to multiply by x, and in the bottom, I'm going to multiply by x plus h. And so what happens here is, well, that clears out my fractions. When I take this expression and I multiply it by the first one, and I'm going to write it out just so that you can see it. Right? If you can do the simplification in your head, do the simplification. So this would be sort of work you might do in your head. So what I'm going to do is basically take all 3 of these terms by x times x plus h. So I'm going to take the 5 over x plus h, multiply it by x, multiply it by x plus h, minus the 5 over x times x plus h, and then the h gets multiplied by x times x plus h. Alright, so like I said, this typically is a mental step. So what you're doing is, the reason why we do this is going to reduce here, right? That equals 1, and so they cancel. We call it canceling. Same thing here. This x reduces with this x, and they cancel it out. So up top, what I'm left with in the first expression is an x times 5. In the second expression, I'm left with a negative 5 times, so I have a negative 5, right? The negative goes with the 5, times x plus h. And leave that in parentheses is important because I'm going to have to distribute. And then in the bottom, I'm left with everything. Nothing simplifies there. I still have an x, I still have an h, and I still have an x plus h. All right. Now I'm going to simplify. It's important that you need parentheses because that 5, negative 5, it's important that it's negative, needs to distribute. So I've got a 5x minus 5x minus 5h. And if a student's going to make a mistake, the most common mistake I see on this is they forget to distribute the negative 5 here, and they just write h. You've got to remember, you multiply the whole thing by negative 5. You distribute. All right, the bottom stays the same. That is not changing, so you just write down the x plus h times x plus h. Up top, though, things are going to simplify. This 5x cancels with that 5x, and so I'm left with negative 5h all over h times x plus h. All right, this was the goal we wanted to get to. Because now, this h, oops, didn't mean to delete it, will reduce with this h, right? H divided by h gives me 1. And it's important that you recognize that that is 1. Alright, that simplifies to 1, because sometimes there's not necessarily a negative 5 there, and so you've got to remember there's a 1 up top, right? H divided by h is 1. And so up top I'm left with a negative 5, alright, because negative 5 times 1 is still negative 5. In the bottom, I'm left with an x times, not plus, x plus h, and then it's simplified. Alright, I'm as simplified as she gets. And if you'll see, now I could, if I wanted to, I could plug 0 in for h, because this will 0 out and just leave me with an x. I can divide by x. Alright, and there's my difference quotient. Alright, so there's part A. There's my difference quotient. Alright, part B. I'm kind of running out of room here. Alright, so part B, we're going to set up the table, so I'm going to erase this. Set my table up here. Alright, so remember, part B was asking you to use your difference quotient and given x values and h values. Alright, and this is going to be my difference quotient. Alright, DQ for difference quotient. Alright, so the x values were 1, the h values were 1/10, 100th, and 1,000th. Alright, and then what we're going to do is, well, we're going to take those numbers and plug them in. And so every time I plug 1 in for x, so x is always going to be 1, it's the h that are changing. So the first time I plug in a 10th. So, and again, I'm just going to plug it in here. And so I'm going to get, and so I'm just going to show you the first time how we plug it in, and then after that I'm just going to give you the numbers that they solve for. Alright, so for the first difference quotient, you're going to plug 1 in for x and a 10th in for h. And so it's going to be negative 5 over 1 times 1 plus 0.1, right? So I'm plugging 1 in for h and 0.1, sorry, 1 in for x and 0.1 for h. And so it simplifies to negative 5 over 1.1. And then you do the division, and it comes out negative 4.5454 repeating. So negative 4.545. I round 3 decimal places because that's the only room I have on my function. Alright, then we're going to do the same thing. And so what this means is, on average, from 1 to 1.1, right, I'm going from 1 to 1.1, the function's decreasing, because it's negative, by 4.54. Alright, now you do the same thing, but for a 10th. So this is only going to change up here. This is going to change to 0.01. This is going to change to 0.01. You take negative 5 divided by 1.01. It comes out negative 4.950. Alright, so it's decreasing faster. Or when that negative went bigger, negative 4.95. Well, now you do the 0, 0, 1. So again, this replaces here, 0, 0, 1. So again, we're going to divide by negative 1.001, and that comes out negative 4.995. And so what we're going to be doing eventually is looking at the pattern here. You'll see the pattern is the smaller value I pick for h, the more negative this becomes, and it's approaching -5 is what we're getting. Again, we're not going to do that more until the next section. But there's my difference quotient, and I'm using it. And so it's finding, so I know on average it's decreasing by almost 5 units for the last piece. Alright, second example is a quadratic type. Alright, and so maybe I'm going to do each of these individually. So I'm going to stick with the... So I'm going to stop there. I'm going to pick up the next video for the quadratic type.